The DNA was designed around speed, not just in the air, but in everything around it. Fast to build, fast to fly, and instantly familiar the moment you launch. Quick lock systems keep setup simple, while the compact design makes it easy to take anywhere. This is DNA. From the first takeoff, DNA feels composed and confident, stable when cruising, precise at speed, and efficient across the entire flight envelope. In this video, I'll show you how to build the DNA, a fully 3D printed aircraft that you can build at home. Most of the airframe is printed from lightweight PLA, while selected parts use different materials depending on their function. Regular PLA is used where additional stiffness is needed. ABS is used for heat-critical parts like the motor mount and VTX mount. And PETG is used for flexible components such as the wing locks. On the website, you'll also find a detailed build manual covering every step of the assembly, along with useful tips, setup information, and recommended hardware. The DNA was printed on my X1C and P1S, but it can be printed from most FDM printers. Thanks to its minimum print build volume of 180 cubic millimeters, it's even compatible with the A1 Mini. If you live in a hot climate and need heat resistance for the entire airframe, I recommend printing the airframe from lightweight ASA. Keep in mind that lightweight ASA may require adjusted temperatures, and a closed chamber is strongly recommended, as the material is more prone to warping. But enough talking, let's get started with the build. For the entire airframe I use medium CA glue. Wherever possible, the design uses alignment tabs to make assembly easier. Insert the tabs in the designated holes, dry fit the parts, and then apply glue along the joining surfaces. Always allow the parts to fully cure before moving on to the next step. If you want to speed things up, you can use activator spray, but I personally prefer to let the glue cure naturally. The fuselage, nose and tail sections come in multiple variants to support different setups. The nose is available in versions for internal or external antenna mounting, as well as a camera-free option for line-of-sight flying. The tail section also includes a variant designed to support Maytag WS2812 LED strips. The wing lock clips feature small notches that prevent them from falling out once installed. Make sure to insert them before gluing the wing mount into place. The clips are not symmetrical and are marked L1R1 and L2R2. Install the L1R1 clips at the front and the L2R2 clips at the rear. Next, glue the FC mount latch into the fuselage. Using a soldering iron, press an M3 threaded insert into the top hole of the motor mount. If any excess material pushes out of the top, carefully remove it with a sharp knife, making sure the motor mount fits properly into the fuselage. For the canopy lock, use a ballpoint pen spring and insert it into the top of the canopy. When gluing the canopy lock, use only a small drop of glue to avoid contaminating the mechanism. While it dries, Move the lock back and forth a few times to make sure it remains free moving. There are 2 flight controller mounts included, one for the SpeedyBee F405 wing and one for the SpeedyBee F405 wing mini. Step files are also included in case you want to use a different flight controller. Insert M3 threaded inserts into the flight controller mount using a soldering iron. Then attach the GPS mount on top using M3 by 6mm screws. The GPS simply clicks into place. Feed the ESC motor wires through the fuselage. Using pliers can help feed the wires through more easily. Attach the motor to the motor mount using M3 by 8mm screws. It's recommended to shorten both the motor and ESC wires as much as possible to keep the airflow inside the fuselage unobstructed. Cooling is handled by the airflow entering the oversized camera opening, with the motor mount acting as the outlet. For this reason, only route the motor wires through one of the 2 holes inside the motor mount. Since the motor is mounted externally and receives plenty of airflow, powerful setups can be run without overheating. Secure the motor by using a M3 by 25mm screw. Insert the M3 threaded inserts into the VDX mount using a soldering iron. The VDX mount supports common VDX sizes such as 20.5mm, 25.5mm and 30.5mm. Camera mounts are available for 20 and 90mm cameras like the DJI-04, All3, Vista and Voxnail. The camera mount is secured by 2 M3 by 4mm screws. If you need custom mounting options, step files for all electronic mounts are included. The complete camera and VDX assembly simply clicks into place. This allows the assembly to slide backward during a crash, significantly reducing the risk of damaging expensive FPV equipment. Servo wire extensions are held in place using a dedicated connector mount, compatible with common JR and MPX connectors. Feed the wires through the fuselage and secure the connectors using 2 M2 by 8mm self-tapping screws. If the aircraft needs to be rebuilt after a crash, transferring the electronics only takes a few minutes. The VTX mount simply clicks into place once the latch is installed. To release it, simply press the latch down at the front. That's it for the fuselage. Let's move on to the wings. Glue the wing sections together using the alignment tabs and the carbon tube as a guide rail. Be careful not to apply glue around the carbon tube holes. Next, glue the aileron sections together using the same method. Make sure the ailerons move freely on the carbon rod without any play. If movement feels stiff, often due to excess filament, sliding the carbon rod in and out a few times usually helps. Apply glue to the pocket in the aileron and insert the servo horn. The wing locks are symmetrical but must be installed in the correct orientation. They are marked with up, which should face upward. Dry fit them first and make sure they sit flush with the wing root. Then glue them into place and remove any excess glue. Insert the rod through the wings and the ailerons. Do not glue the rod. This allows parts to be reused if needed. Mount the servos to the servo covers using M2 self-tapping screws. I'm using KST servos here, and I can also recommend Sevox servos. They offer excellent quality at a reasonable price. For fast setups especially, high quality servos are essential. Attach the servo cover to the wings using M2 by 8mm self-tapping screws. The linkages consist of M2 clevises, ball joints and threaded M2 rods. Attach the linkages to the servos and feed them through the second part of the servo cover. Secure it with self-tapping screws, then connect the linkage to the servo horn using an M2 screw and nut. If the nut isn't self-locking, add a drop of glue to prevent it from loosening over time. That's it for the build. If you liked this video and don't want to miss upcoming projects, please consider leaving a like and subscribing. Also let me know what you think in the comments. Thanks for watching and I hope to see you in the next one.